Hi students, we are continuing the balance problems of electricity. The figure shows a battery of 9 volt and internal resistance 0.6 ohm connected to 3 resistors A, B and C. Calculate the current in each of the resistor. Okay, so it shows that the voltage is 9 and the internal resistance small r is equal to 0.6. We need to calculate the current through each of the resistors A, B and C. Okay, so first of all let us calculate the effective resistance of the circuit, and you now know that the resistance B and resistance C forms a parallel combination. Okay, so on calculating the resistance, 1 by Rp equal 1 by 4 plus 1 by 6. On solving we get Rp is equal to 2.4 ohm. So this 2.4 and this 2 are in series, therefore the series connection Rs is equal to 2 plus 2.4, which is 4.4 ohm. Okay, since it is mentioned about the internal resistance of the cell, you need to consider that too for calculating the total resistance. Therefore on summing this also we get 4.4 plus 0.6, which would be 5 ohm. So the total resistance of the circuit will be 5 ohm. Okay, the total resistance of the given circuit will be 5 ohm. Now let's calculate the current in the circuit. Okay, and you should be knowing that the current in the total circuit will be the same current passing through the resistance A. So current through the resistance A will be equal to the total current in the given circuit, which is given by voltage divided by resistance. Okay, since the voltage is 9 volt and the resistance is 5, the current through the entire circuit is equal to the current through resistance A, which is equal to 9 by 5. Upon solving we get the current as 9 by 5, which is equal to 1.8 ampere. So the current through the first resistor IA is equal to 1.8 ampere, because the entire current passes, the total current in the circuit is same as the current which passes through the resistance A. So the current through the resistance A is 1.8 ampere. Okay, so next we need to calculate the current passing through the resistors B and C. Okay, so let's look at the figure. So now you need to be cautious. As we have discussed in the earlier classes, the current through the entire circuit is equal to the current passing through the resistance A, which we have calculated to be 1.8 ampere. Okay, which we have calculated to be 1.8 ampere. This 1.8 ampere splits up and enter into the resistors B and C. Okay, let's say that I is the amount of current which entered to the resistance B. So what are we left with now? It is the total current in the circuit is 1.8, out of which I current passed through the resistance B. So 1.8 minus I current passed through the resistor C. So the current which enters to the resistance C is 1.8 minus I. We know that this B and C forms a parallel combination, therefore the voltage across them will be same. Okay, now we can equate the voltage across B and C to get the value of I. Okay, so here I have clearly indicated that let I be the amount of current passing through the resistance B. So the current which passes to the resistance E will be 1.8 minus I. Since RB and RC is in parallel, the voltage across them will be same. The resistance of B is 4 ohm and the current I is a current through it is I. So the voltage will be 4 into I, and the resistance of C is 6 and the current passing through the 6 ohm is 1.8 minus I. So the voltage will be 6 into 1.8 minus I. Upon solving we get cutting this 4 and 6 by 2, we get 2I is equal to 3 into 1.8 minus I. On solving we get I is equal to 1.08 ampere, which means that the current passing through the resistance B, IB, is equal to 1.08 ampere. So the current passing through the resistance C will be nothing but it is 1.8 minus 1.08, which is equal to 0.72 ampere. Okay, I hope this concept is clear to everyone. Let's try solving another question. Next is, in the given figure, A, B and C are 3 ammeters. The ammeter B reads 0.5 ampere. So the ammeter reading of the ammeter B is 0.5, which suggests that the current passing through the ammeter B, that is IB. IB is nothing but it is 0.5 ampere. First of all, we need to calculate the readings of the ammeter A and C, which is the current passing through the. So we need to calculate the current passing through resistance A and current passing through resistance B, resistance C we need to calculate. Okay, so let's move on. So let us first calculate the total resistance of the circuit. Okay, we know that the B and C forms a, here the resistance B and C forms a parallel combination. Okay, so let's calculate the resistance 1 by Rp is equal to 1 by 6 plus 1 by 3. On solving, Rp will be equal to 2 ohm. So series resistance Rs is equal to 2 plus 2, which is equal to 4 ohm. So the total resistance in the circuit will be 4 ohm. Okay, that is our second question. The total resistance in the circuit, the total resistance is found to be 4 ohm. Now we need to calculate the current passing through the resistance A and resistance C. Okay, since we know that B and C are in parallel combination, the voltage across them is the same. Okay, so we can say that 6 into the current passing through B is 0.5, which will be equal to the current passing through C is to be found out. Okay, the resistance of the C is 3 into, let's say that the current passing through C is I. On solving, we will get the current passing through C is equal to 1 ampere. Okay, cutting this twice, so 2 into 0.5, which is equal to 1 ampere. So the current passing through the resistance C will be 1 ampere. Okay, so now if you look, this total current in the circuit will be the sum of the current passing through the resistance B and resistance C. Okay, so therefore the total current I is equal to 1 plus 0.5, which is equal to 1.5 ampere. Okay, this same current will pass to the resistance A. So current through the resistance A will be equal to 1.5 ampere. Okay, I hope this question is clear now. Moving on to the next one. Observe the diagram given below and answer the following question. Calculate the resistance of the circuit when the key K completes the circuit. Okay, so when the key K completes the circuit, the current starts flowing and all the resistance will be added up in the circuit. Here we know that the 5 ohm and the 3 ohm forms a series connection. The 5 ohm and the 3 ohm forms a series connection, and the 2 ohm is in parallel with them. So let's find the series resistance first. Rs is equal to 5 plus 3, which is equal to 8 ohm. Okay, so now this 8 ohm and 2 ohm forms a parallel connection. Moreover, we need to consider the total, in order to find the total resistance, we need to consider the internal resistance of the cell, which is 0.4 ohm also. Okay. So basically, first the resistance across series is equal to 3 plus 5, which is equal to 8 ohm, and now the parallel, because this 8 and this 2 forms a parallel combination. So 1 by Rp is equal to 1 by 2 plus 1 by 8. On solving, Rp will be equal to 1.6 ohm. Therefore, the total resistance R is given by 1.6 plus the 0.4, which will be equal to 2 ohm. Okay, therefore the total resistance of the circuit is given will be equivalent to 2 ohm. Now we need to calculate the current passing through 3 ohm resistance when the circuit is complete. Okay, the current passing through 3 ohm resistance when the circuit is complete. Okay, so we know that this 2 ohm and this 5 and 3 ohm forms a parallel connection. So the current through them is different, but the voltage through them will be the same. That is, the voltage across the 2 ohm resistance will be equal to the sum of the voltage across 5 ohm and 3 ohm. Okay, so let's say that this 2 ampere current split up and enter into the 2 ohm and this 5 and 3 ohm series connection. Let's say that I current enters through this branch, then the amount of current entering to this branch is, the total current is 2, right? 2 minus I. Okay, so the amount of current entering to this branch will be 2 minus I. Okay, and the amount of current entering through this branch is I. So now we know that the voltage will be the same. Okay, the voltage across them will be the same. So the voltage across this will be 2 into 2 minus I is equal to, the voltage across this is 5 into I plus 3 into I. Okay, on solving, opening the bracket, we get 4 minus 2I is equal to 8I. Okay, therefore 4 is equal to 10I. Therefore, I is equal to 0.4 ampere. That means the same, since 5 ohm and 3 ohm are in series, it is the same current which passes through both of them. So the current which passes through the 3 ohm resistor when the key closes the circuit is nothing but 0.4 ampere. All you need to use is the basic concept. When in a parallel combination of resistances, the voltage across each of them will be the same, but the current will be different. And for a series combination of resistance, the current through each of the resistance will be the same, but the voltage across each of the resistance will be different, and the total voltage would be the sum of the two. So I hope all the problems which I have discussed are clear to you. If there is any concerns, any doubt, or any suggestions, you can post down in the comment section. If you find my videos helpful, kindly like, share, and subscribe. Do leave a positive comment. Thank you, and see you in your next class.